So this is a small follow-up to my capacitor replacement video I just put out, like maybe it was a week ago now when you're seeing this, but I've been still working on the same power supply, replacing its old capacitors from 20 years ago. Mostly they are Tiapo. They are the terrible branded ones that the Fuhu Yahoo or whatever. The ones that are the worst, focus on that, please. There we go. Those type that don't even say it, they just have that logo there, and I know what that means. It means they're terrible. And I've had to replace one of those and some Tiapo ones as well. There's this one I replaced. Some of them are brown like that, and they have the date code 0901 from 2001. SEK series. There may have been another one I replaced. I can't find it now. But basically the output capacitors are mostly Tiapo and also Jamicon, which I've heard mixed things about. I can't tell by looking it up whether this is a good cap or a bad cap. And some of them are completely fine. Of course, they read, since they are from 2001, with the date code there, they read extremely high capacitance and very high leakage, which typically indicates that they are faulty. And I tried to reform some, so this one here I've spent a long time reforming, because I'd rather not replace these. These are very high capacitance ones. I don't have a lot of 4,700 microfarad capacitors that are good. And these ones typically go bad the fastest and such, so I'm just going to set the meter there. So when you reform these, I almost took that up backwards, I caught myself there. When you reform these, you want to make sure you got the polarity right. And turn on the power supply. I have this one, it's a 10 volt capacitor. I'm reforming this at 7 volts because it filters the 3.3 volt rail, I think. Or 5 volt, no matter what, 7 volts is probably good. So now the voltage is going up. 5 volts, 6 volts, 7 volts. Now let's see the leakage. The leakage should be less, I already did the math on this one, less than 300 microamps. And as you can see, it was way over before. I didn't show the process of reforming it, but it was like all the way over there. I let it reform, and now I have less than 100. I have less than 50, actually. So this thing came back to life in like half an hour. And it's been sitting, and I just tried it again, and it immediately goes down to excellently acceptable ranges. Now, of course, I'm going to go ahead and turn the power supply off, discharge it, like that. Now, of course, that doesn't mean it's necessarily still good. It means I fixed the, I reformed the capacitor, I fixed the high leakage current. If we go ahead and still look at the capacitance, actually, I'll probably just go ahead and use this capacitance meter over here. If we go ahead and put this on here and measure the capacitance, it's still very high capacitance, but at least there's less leakage. What shows up here is voltage loss. So testing, it's very high capacitance. So it's about 5,300 microfarads, but 0.00 ohms ESR. And just so that's not a glitch, I'll try it again. It might pick up 0.01 this time. 0.02. That's still fine. 2.5% voltage loss. So higher capacitance, but at least the ESR is fine with this. Looking at my chart up on the wall, I don't know if you can see that. It's quite hard to hold a tripod, but the 4,700 microfarad at 10 volt should be 0.04 or below. And it is. It is consistently 0.01, 0.02, so it's fine. So this thing is fine, this Jamicon one, but right next to it, there was also this thing, which is another focus on that. I'm getting a new camera, guys. This is ridiculous. Another Jamicon one. It looks completely different. Like, they're not even the same color. And this one right here is the TM series, apparently. And this one right here is the TK series. 105 degrees rated, etc., etc. Jamicon. But look at the top. It's bulged. That was really not obvious. There's a worse one that I have yet to take out, but this one caught my eye as well. It is bulged, and there is some goo on the top. Very hard to see. But let's go ahead and try to test this one. And this is kind of funny, because when your capacitors test like this, you know they're bad. Focus on that. Oh, quite strange. Okay, well, we have 1,500 microfarads, 30% voltage loss, and ESR of 1 ohm. This is supposed to be 3,300 microfarads. Let's try it again. Hopefully it'll have the little funny thing that happened. Nope. Okay, I tested this like 7 times before, and it was testing like a diode, which apparently it's not going to do now. It was testing like a diode with a huge junction capacitance. So I've had several caps test like that are just completely gone. I think that's hilarious. There we go. There it is. It tests as a diode with 1,001.41 millifarads capacitance and a voltage drop of 250 millivolts. That's hilarious. I don't know why, that's just really funny. So, if you try and reform something that's this far gone, we can go ahead and try. I don't want it to explode. That would not be good. So again, I'll give it the good old 6 volts this time. I'll try 6 volts as a 10 volt capacitor. So here we are in the 100 milliamp scale. I'm going to turn on the power supply and get ready to turn it off fast. Alright, you can't see it now because I don't have the setup. Voltage is going up and up. 5 volts. 6 volts. Alright, let's look at the current. It's going down, and now it's going up. So yes, if you try and reform something that's this far gone, the current starts going up. So it's failing right now. It's breaking down inside. This is on the 10 milliamp scale, so right now we're at 3 milliamps. And we're about to hit the current limit of the supply that I have, so yep, this is gone. It's going up, so there's no point. And already it's quite hot from that. So, yep, that's what happens if you try and reform a capacitor that's too far gone. Alright, thanks for watching. Jamicon, yeah, I don't know what to think about them. There's like several good ones in there, and there's like 2 bad ones, so you win some, you lose some, I guess.